Hi class, welcome to exercise 10H, solving polynomial equations. In this lesson, your examples and pre-learning will be example 16, using the null factor law. And your pre-learning for this example will be questions 1 and 2 in the new book and question 3 in the old book. Then we'll do example 17, which is factoring and solving. And your pre-learning for this example will be questions 3 in the new book and questions 4 in the old book. So while there might be some reminders throughout this lesson, we're still assuming that you understand the null factor law, are confident with solving quadratic equations, and comfortable with the remainder theorem. If you have any doubts about the first two there, you should go back and look at the quadratics unit, and if you have any doubts with the last one, then check over our last lesson. Alright, I'll see you in the introduction. Recall that when we're solving a quadratic, we would move all terms to one side. So for example, we'd want to see 3x squared minus 3x minus 2 equal to 0. So as you see, we've got all those terms on the left-hand side. So that would mean if you're presented with 3x squared minus 3x equals 2, well, you'd subtract the 2 from both sides, so you end up with 3x squared minus 3x minus 2 equals 0. Or if you're presented with something like 3x plus 2 all divided by x equals 3x, well, first we'd multiply both sides by x, and then we'd rearrange the equation so we've got all the terms on the one side. So it didn't matter how we started off, we always wanted to rearrange the equation so we ended up with the same equation as we have at the top there. Then once we've done that, we could use either factorization with the null factor law, or we could use the quadratic formula. When solving a cubic polynomial, we must use factorization and the null factor law, because while a cubic formula exists, it is too hard to use. I mean ridiculously hard. If you don't believe me, you can check out this video by Mythologer. And if you look at the playlist of these videos, you'll notice I've put it in there as well. Alright, so let's talk about factorizing for the cubic polynomials. So after doing our quadratics unit, you know that quadratics sometimes have no solutions, where linear graphs always had a solution. And just like linear graphs, cubics always have at least one solution. Now you know what's going to happen with a linear function, but if a was a positive number, then when I square negative a, that's the same as squaring a. But if I cube negative a, that's equal to minus the cube of positive a, which is why it operates like a linear. And I could go through some complicated algebra with you right now, but just trust me, you're going to see why this is true when we graph them. So we know there's going to be one solution, so how many possible solutions could there be? Well, there could be 3 solutions, i.e. if I had 3 linear factors, then I know where this would be 0 using the null factor law, because that would be where one of the factors would be 0. So that would be either x minus a equals 0, or x minus b equals 0, or x minus c equals 0. And with some simple algebra, that means that where x is equal to a, or x is equal to b, or x is equal to c. Another possibility is that we've got 2 solutions, and that would be a cubic where we've got a linear factor times a square factor. So then by the null factor law, either x minus a is equal to 0, or x minus b squared is equal to 0. And that means obviously that x is equal to a, or x is equal to b. Oh, I should have written null factor law up here, by the way. And just to be clear why we've got only 2 solutions, x minus a times x minus b squared is actually equal to x minus a times x minus b times x minus b. And of course they're 0 at the same place. When we get to graphing, keep an eye out to what that actually means, by the way. Alright, and there's one other possible set of solutions, and that is when there's one solution. And that would be where we've got either a perfect square, and that means we've got 3 repeated linear factors, right? So that would be 0 when x is equal to a. I forgot to write null factor law again. But there's another possibility as well, and that is when you've got x minus a times x squared plus b. And once again, using the null factor law, obviously x minus a is equal to 0 and x squared plus b is equal to 0. And the first factor is 0 when x is equal to a, so there's one solution. But the other one is 0 when x squared is equal to minus b, and that's got no solutions. Just note that I've used this x squared plus b as an example. That could be any quadratic with no solution. And another point I want to make is that these a, b's and c's could all be 0. So for example, we could have x minus a times x squared. So how do we go about finding these guaranteed linear factors? Well, we're going to use the remainder theorem. Told you it was a cool trick. So as a reminder, that would mean that we've got a polynomial and we could express it as some linear factor times a quotient plus the remainder, just as we worked with in the last class, right? And we also saw that if we subbed in b for x, then our divisor here became 0, and we're left with polynomial of b is equal to the remainder. And if the remainder is equal to 0, that would mean that x minus b is a linear factor. So the way we do this is we're going to use trial and error to find what b is. So as an example, we've got a polynomial here of x cubed plus 6x squared plus 5x minus 12. Now as a little clue, I know that b is not going to be equal to 0 because we've got that minus 12. Because that means subbing in x equals 0, we're definitely going to have a remainder of minus 12, right? Let's do a trial and error here. And remember what I said in our last class, that we're not going to be too harsh on you. So you're probably going to be looking for factors of minus 12. So let me start with p of 2. So we'd have to sub in 2 for x there. And that means we've got 8 plus 24 plus 10 minus 12, which is equal to 30, which is not 0. Therefore, x minus 2 is not a factor. Let's see if b is equal to minus 1. So of course we're going to sub in minus 1 for x. So we've got minus 1 plus 6 minus 5 minus 12, which is equal to minus 12, which is not 0. So that means that x minus minus 1, or x plus 1, is not a factor. Alright, let's try p of 1. So subbing in 1 for x there, we've got 1 plus 6 plus 5 minus 12, which is equal to 0. So therefore, x minus 1 is a factor. So now we've got a factor, the next step is to do division to find the other factors. So if we know that x minus 1 is a factor, we should divide that polynomial by x minus 1. So I'm trying to get rid of x cubed here, so x squared times x minus 1 is x cubed minus x squared. So I'll put my x squared up the top there and subtract that away, which will give me 7x squared plus 5x minus 12. So I want to get rid of the 7x squared, so 7x times x minus 1 is 7x squared minus 7x. Putting up the 7x at the top and starting to subtract away, we get 12x minus 12. So I want to get a plus 12x here. So that's 12x minus 12. Putting the plus 12 at the top, subtracting away, we get a remainder of 0. So if you remember from our previous lesson, that means that x cubed plus 6x squared plus 5x minus 12 is equal to the divisor x minus 1 times the quotient x squared plus 7x plus 12. So now that we've got one linear factor, we must factor x squared plus 7x plus 12 with quadratic techniques. So because 3 times 4 is 12 and 3 plus 4 is 7, that means that this must be x plus 3 times x plus 4. So subbing that back in, that means that our polynomial x cubed plus 6x squared plus 5x minus 12 is equal to that divisor x minus 1 and x plus 3 times x plus 4 in the place of the quotient. So we could check that with the remainder theorem. So if x plus 3 is a factor, then p of minus 3 must have a remainder of 0, right? So let's sub in minus 3 into our polynomial here. And so that means we've got minus 27 plus 54 minus 15 minus 12. And 27, 15 and 12 also makes 54. So we've got minus 54 plus 54, which is 0. Ka-ching. And then we could find p of minus 4, but I know that's going to be equal to 0. You can either trust me or check yourself. Alright, so that's a brief introduction. I will go into a little bit more detail in the sections, but because we're working through a challenging area at the moment, I do recommend that you pause the video and do the building understanding questions if you have the new textbook, which translates to 1 and 2 in the old textbook. Alright, we'll see you in that next section. So the idea of the null factor law is that any number multiplied by 0 is 0. And we use this fact with quadratics when talking about two numbers. And if their product was 0, that meant one of them was. But the null factor law could involve the product of any amount of numbers. So therefore, if we had three numbers A, B and C times each other and they were equal to 0, then at least one of A, B or C is 0. So then if we looked at it from the point of view of a cubic polynomial, if A times x minus b times c times x minus d times e times x minus f was equal to 0, then by the null factor law, either ax minus b is equal to 0, or cx minus d is equal to 0, or ex minus f is equal to 0. So then to find the x values, we're going to solve for x here. So that means that either a times x is equal to b, or c times x is equal to d, or e times x is equal to f. And therefore we know that this is going to be equal to 0 when x is either equal to b divided by a, or d divided by c, or f divided by e. Okay, so let's put this into play with the example 16, where we're going to solve the following polynomials for x. So in part A, our polynomial is x minus 1 times x plus 2 times x plus 5, and we want to know where that equals 0. So clearly that means that one of those factors is equal to 0. So by the null factor law, x minus 1 is equal to 0, or x plus 2 is equal to 0, or x plus 5 is equal to 0. And it won't take a genius to realize that that means x is equal to 1, or x is equal to minus 2, or x is equal to minus 5. Alright, nice and easy, eh? Let's go on to part B, where the polynomial is 2x minus 3 times x plus 3 times 3x plus 1. And of course we want to know where that equals 0. And the null factor law will state that that means that 2x minus 3 is equal to 0, or x plus 7 is equal to 0, or 3x plus 1 is equal to 0. Alright, so these aren't as straightforward because we've got some multiples of x in a few of these. So let's have a look at the first one. If I add 3 to both sides and then divide both sides by 2, we've got x is equal to 3 on 2. And straightforward for the other one, that's x equals minus 7. And for this one, we have to subtract 1 from both sides and divide by 3. So we could say x could also be equal to minus 1/3. Okay, so we've got our three values where this polynomial could be 0. At this point, you should note that it might be an easy start to this lesson, but this is really all you're going to do with what might seem tough to you later on. The only difference is you're going to have to do the factoring yourself. Alrighty, pause that video now and do questions 1 and 2 if you've got the new book, or questions 3 if you have the old book. And then I'll see you in the next section. Factoring and solving is a 4-step process that relies upon the remainder theorem. So let's recall the remainder theorem, which is about a direct relationship for a linear divisor, x minus a. And because a polynomial x is equal to this linear divisor times a quotient and an extra remainder, then if we had x equal to a and sub that in, Then we'd sub in a for all values of x, and we'd be left with a minus a times the quotient of a plus remainder. And because a minus a is equal to 0, and 0 times quotient of a is also 0, then the polynomial at a is equal to the remainder. So in other words, if I want to know what the remainder is after dividing by x minus a, I just sub a into the polynomial. And of course, the definition of a factor is when the remainder is 0. So if I have a polynomial at a value a equal to 0, then that means that the divisor x minus a must be a factor. So with this in mind, this means that our 4-step process is: step 1, use trial and error with the remainder theorem to find the divisor. In other words, keep trying different a's so that the polynomial of a is equal to 0, and that would mean that x minus a is a factor. Then step 2, we use polynomial division to find the quotient. Then step 3 is factoring the quotient, and this may require some quadratic methods. And then step 4 is to use a null factor law, and therefore the polynomial is 0 for each x value that makes each factor 0. And of course, it's worth noting that there will always be at least one linear factor of a cubic. Alright, let's try this in example 17, where we're going to solve x cubed plus 2x squared minus 5x minus 6 equals 0. Alright, so step 1 was using the remainder theorem. And my hint for you is to focus on that minus 6. Look for factors of it, i.e. plus or minus 1, 2, or 3. So just quickly write that out in polynomial form. So let's try 1. And 1 plus 2 minus 5 minus 6 is minus 8, which is not 0. Therefore, x minus 1 is not a factor. And of course I say x minus 1 because it's x minus what we've subbed in for x here, okay? So polynomial at the value of 2 is equal to 8 plus 8 minus 10 minus 6, which is 0. So because we've put 2 as our x value in the polynomial, that means that x minus 2 is a factor. So we've done step 1, we've found a factor. So let's do step 2, which is the long division. So of course that's x cubed plus 2x squared minus 5x minus 6 divided by x minus 2. Now I want to get rid of the x cubed, so x squared times x will give me x cubed. So that is x cubed minus 2x squared, putting the x cubed up the top. And when I subtract that away, we're left with plus 4x minus 5x minus 6. I mean plus 4x squared. So now I want to get rid of the 4x squared, so 4x times x minus 2 gives me 4x squared minus 8x. And of course writing the 4x up the top here. And subtracting that away, we're going to have 3x minus 6. Okay, minus 5 minus 8 is plus 3, of course. So multiplying that by 3, we get 3x minus 6. Don't forget to put the 3 up the top. And of course, subtracting that away gives us 0. And that's what we expected, right? It should be a remainder of 0 because it is a factor. So that means that our polynomial can be rewritten as x minus 2 times x squared plus 4x plus 3. Okay, because the x minus 2 is a divisor and the x squared plus 4x plus 3 is the quotient. Okay, so we've got a divisor, we've got a quotient. All right, let's do step 3, which is factoring that quotient. And 1 times 3 is 3, 1 plus 3 is 4. So that means that x squared plus 4x plus 3 has to equal x plus 1 times x plus 3. So looking what we wrote there in step 2, we can now say the polynomial is x minus 2 times x plus 1 times x plus 3, with those last two there in place of the quotient that I had in the other part. Okay, part 4, using null factor law, p of x equals 0 when x minus 2 is equal to 0, or x plus 1 is equal to 0, or x plus 3 is equal to 0. So that means that x is equal to 2, or x is equal to minus 1, or x is equal to minus 3. Now I'm not going to do it here, but you could easily sub in x equals 2 or minus 1 or minus 3 into the initial polynomial and see that it will give you 0. Alright, and I just want to make another note here that 2, minus 1, minus 3 are all factors of minus 6. And as I said, you should look out for that when we've only got x's on their own. They're not multiplied by anything. Alright, there's a lot of work here to do. I don't expect it to be easy first time around, but with a bit of practice and taking the notes down for the 4 steps, as long as you've mastered the remainder theorem, you will get this, okay? So, pause that video now and do questions 3 in the new book, or if you have the old book, do question 4. And then when you come back, we'll summarize this lesson. Alright, you've probably heard this before from me, but please make sure that you complete your pre-learning thoroughly in this lesson. Not only do you need to be sure that you've mastered the key skills, there is some extra stuff that we really need to be covering in problem solving during class time. Okay, so for this lesson, a successful student will know how to find a factor of a polynomial using the factor theorem, be able to factorize a polynomial using division by a known factor, and finally be able to apply the null factor law to solve a polynomial equation in factorized form. Alrighty, good luck everybody. Keep working hard. We'll see you in the classroom or the next video. Bye.